Bismillah ar-Rahman ar-Rahim. This is a question we have, June 2020, 41 variant. And the question is, what given a particle P is thrown upward with a speed of 5 from point A, which is 2.8 meter above the ground. Many students don't make a diagram. That is why they get issues. So look the way how I do this question. This is a ground level. This is a ground level. I said before, these kind of questions always make a rough idea and then try. So particle thrown from here, first particle goes up, stop on the peak, and then from here, it will come down. This is a whole process. So first it goes up and then comes down. And what a question, launching speed is given as you can see here, 5. And he said it is a 2.8 meter height. So 2.8 meter height. So this is from here to here is 2.8 meters. This gap is, height is 2.8 meters. Okay, so it starts from here. Goes and comes down. First question, find the greatest height above the ground at P. So it means at this point, common sense, last speed is 100% zero. So we have 3 formulas. You know it very well. So I think which formula will help in going upwards, gravity always -10. Coming downwards, always gravity +10. You know this basic criteria. Okay, now have a look now here. So I have to use V, U, gravity, and S is my, height is my target. So S is my question mark. So I think the third equation of motion is helping us. 2as equal to V square minus U square. 2 times to -10, S is a target, last speed and the peak is 0. His starting speed as a 5. This is becoming -25 and is a -20s. So it goes down -25 by -20. So I get answer 1.25 meters. But he said, no, give me from ground. So actually I got this 1.25. He said, not from ground. So I must add 2.8. So from ground. So total height becomes 1.25 plus 2.8. So if I add, I get 4.05 meters. And I believe this point is very, very clear. So first part is totally finished. Part number 2. For part number 2, students, this diagram, I will make a copy again. I will copy the whole diagram again, and I will do it again. So have a look, students. So copy. Okay. All right. So here I'm going to make it here. So concentrate. This is a diagram, but in this diagram, what is the situation we have? So the condition is a little changed now here according to the question. Let's see now what a question is. Okay, he's saying find length of time. He's not asking time. No, length of time. So length of time is my target, for which P height is more than 3.6 meter above the ground. Interesting part, 2 things are important: length of time and more than 3.6 above the ground. So let's see, I make it's a blue line here. So I think you understand this is a blue line. So from ground to this is 3.6 meters. So from 3.6 meters, subtract 2.8 meters. So this height will naturally becoming what? 0.8 meters. Now question comes, so you can ask me, okay, actually, you know, I just give you a small idea. Particles start from here, move. When it reach here, first time reach here. This first time it crosses the height of 3.6 meter. Stopwatch on here. I will count this as a T1. Go up, and coming down, reach here. Again, this reach at this position. This is called T2. And my stopwatch will off. Why? Because again, it is reach a height of 3.6 meter. But he said more than 3.6 meter. It means the whole journey, this journey, he talked about. So we need 1 time and we need 2nd time, and we will subtract these 2 times. Why? Because he asking not these 2 times. He asking the length of time. The length of time is how much gap here, gap here. So now let's start now. Formulas, we have many, 3 formulas. V equal to U plus AT or GT. S is equal to UT plus half AT square or GT square. And third is a 2AS is equals to V square minus U square. Wait a minute, please. Yes, student, okay, listen to me. This formula is not helping us. Reason, because I have to put distance. There's no distance for variable available there. So this formula gone. So this formula, can I use it here? Again, flop. Reason, because we don't know. We are not, we have no concern with the final velocity here. So that is why we can't use this formula. So now this formula will help us because starting speed, we have it. Okay, this S, we have it, and T is my concern. So this formula, because I, as a teacher, I know that many students can confuse while pick and choose the formulas. I hope so you got idea. Now this 0.8, I will plug in reason because this is a full 3.6 and this 2.8. If we subtract this point 0.8, because particle is starting from this point, that is why I can't count 2.8 distance. I will not take it. Logic is very clear. Particle not starting from bottom, starting from this point. So I will take 0.8 only. So let's start. 0.8. U is 5. You know it very well. Sorry, U is 5 here. So 5 T and plus half times to gravity going upward -10 always. 0.8 is equal to 5t minus 5t to power 2. Bring all value left hand side. I get it this kind of thing, and positive and negative and positive. Now I have two choices. I think I will go for quadratic formula. Minus b plus and minus, and b square minus 4a into c and divided by 2a. So you just show this much. No need to show extra working. And I think so if I type in calculator, I got two answers. So 0.2 comes and 0.8 comes. Hold on, I repeat. This is a time when it reached first time and again a height of 3.6 from the ground. And this is a time when it gains a second time, same height from the ground. So we don't need these two times. No, we need a time between the traveling this one, because all journey above 3.6, even he mentioned above. So I have to write time how much? How? So 0.8 minus 0.2, and I believe you got a whole picture clear and question is over.